Okay, hello. So this is week 8 of Intro to Microeconomics, and I'll start in a few minutes. So in the meantime, if you have any specific questions, either from the previous week course content or from this week or from previous assignments, you can let me know. You can like just type into the chat or you can unmute yourself and speak and tell me, and I will take it up in the class. So just waiting in case a few people will be joining because it's not exactly time yet. So you will start in just 2, 3 minutes. Okay, so I think last week's mm, notes were left. Like I think I did not upload that, the full thing. So I'm just uploading that now. So I think most people have logged in already. Okay, so just for everybody's information, like if you have any questions from the previous week or from this week in the previous assignment or in the content of this week or last week or any week, please let me know so that I can. Uh, so the reason why I have not uploaded the previous classes class notes is because there is some issue with OneNote. So last week was like a very complicated week. Um, as you know, I kind of uh, couldn't upload the file for week 7. That is basically because OneNote is not. Even now, I'm trying. It's not uploading it. It's not uploading it as PDF. It's uploading it as some random file. So I'm still trying to figure out how to resolve that. And there is a video from previous week, the remaining of the lecture, or I mean the tutorial session, which has not been uploaded, which again, I'm having some tech issues in my computer. So, I will upload it. It's still there on the to do. I haven't forgotten about it or anything. Yeah. And so that exercise from the previous assignment, like the previous week 7, I had given an exercise in which you had to calculate the Marshallian and Hicksian demand. Yeah, so I asked you to post that in the discussion forum because I don't see any link there. So you have to tell me where that link is and where you are asking for that because I don't know which notes you are referring to. You posted it. I don't see your question in the discussion forum. Is it there in the Q&A? Have you posted it in the Q&A? Let me just open that. Yeah, I think you posted it now, last night or something. So I will ask them. Okay. So yeah, let me just complete what I'm saying first, otherwise I'll forget it. So well, like I was saying from the previous class, that question, I will upload the video for that question. And for the question, I'll just show you which one. So apart from that, I will take up another question today with the same kind of setup where you calculate Hicksian and Marshallian demand, and that will hopefully help clear doubts on that topic. And then after that, we can move on to producer theory, which is what we already started last week, actually. Okay, let me see what you guys are saying. Question number 6, 8, 10 from week 7 assignment. You mean the assignment on NPTEL, Swayam portal, right? Let's see, what is this? Right. Okay, hang on. Yes, okay. Let me just open the week 7 assignment. And in this you're saying question number 6, 8, and 10. Okay. 6, 8, and 10. Okay. So I don't know if you paid attention to the question. Actually, this question in a different way I had already covered in class in the previous class. I don't know if you realize that, but part of that question in a slightly different way I had already covered in the class last time. So let me go back to the question. Yeah. So I gave a question in the class, Charlie consumes apples and bananas. Okay, so this is her utility function. X1 is okay. Okay. And effect. Okay. And 10 is okay. So I'll come to this question. Any other questions anybody has? So somebody wants me to cover this week's material. No, I will be covering this week's material also. I didn't say I will not talk about it. There's one question, but I did want to cover it because I don't think everybody is clear on Hicksian and Marshallian demand and income and substitution effects. So I can't do producer theory first and then go back to consumer theory all of a sudden. So I have to complete that part first because somebody asked a question from the assignment also, and then I will start producer theory after that. Okay, let me just open last. Okay, I'm just sharing last week's question and you can see if this part was clear to you or not. Right. Okay, so this part you guys solved in class last time. So uh, was any issue with this, or like this we discussed in the class? So is there any problem with this? Is this part clear at least? Open too many windows. Can't see the chat now. Yes, I'm just asking that this question was okay because the rest of the thing in the assignment is this question itself, but expanded on this question. So what is the indirect utility function? Does anybody know? How do you solve for the indirect utility function? Okay, let me connect to my iPad here. Okay, so I think your main issue is with the indirect utility function, if I'm not mistaken, right? Because that is what they've asked, whether it is increasing, non-increasing, non-decreasing, whatever, right? So, ouch, bit of a space crunch. Okay, so say suppose you have two goods. Let me write the question here first. All right, so say suppose your utility function as it is given is u1 is u is equal to x1 x2. That's what's given, right? Then yeah, and what you're given is initial, let's assume p1 and p2 are the prices, okay, for x1 and x2 respectively. So if say you can call income as m just to avoid confusion with say indifference curves and things like that, we use a different letter, like we use the letter m a lot of times to denote income. Okay, it's the same thing. So m is equal to p1 x1 plus p2 x2, and this is how we normally write it, isn't it? Let me go back to the question. So what they're trying to ask you is the utility function is a function in x1 and x2. What they're trying to ask you is the indirect utility function, in which you are actually trying to express it in terms of not x1 x2, but you try to eliminate x1 x2, but in terms of m and the prices which are given. So in this case, when you solve it out, one second, I think I had it somewhere already. Okay, let me come back to indirect utility function in a few minutes. First, let me do this 8 and question 10, and then I will solve this. This will sort of, that will be a bit better. So from here, I think you can also try it out yourself. Did you attempt to solve for the indirect utility function? What we have here is something like this. So what you will do is you will basically not take m and p and all as values which are given to you. When you're solving for a function, the main difference is that instead of taking p1 and p2 as 1 and 2 or something, whatever is given, you take it as just sort of parameters, right? Because what they want to see in the indirect utility function is how is your utility varying with prices and with your change in income. So what we do in indirect utility function is we try to express it in terms of P1 and M, or you can call it as I or whatever you want to call it, instead of just the instead of the um, consumption variables, which is x1 and x2. Okay, we will come back to this. Let me first solve the rest of it because I think that is in continuation of what we did in the last class. This has been recorded, right? Yeah. Okay. Okay. So 7 is after price change, and 8 is income effect of fall in price. It's the same as in. Okay. So how do you calculate income effect? Any ideas? So nobody else asked me a question, so I'm assuming everybody knows. Is that so? Does everybody else know how to calculate income effect? Any ideas? Anybody wants to attempt the answer? No? Okay, so income effect is, how do you get that? Okay, first let's understand what is total effect and how it relates to both the effects. So this, I hope everybody will agree with me this much. Yes? Mm, So this much, I think everybody agrees with me. You can just type in yes or no in the chat. I just want to know if how far back I have to go to explain, because I don't know how much you guys have understood. So let me just write this as short. Okay, it takes a lot of time to write. So now if we know the total effect and if we know the substitution effect, we can calculate the income effect, right? That is just another way of, there is a way to calculate income effect directly also, but it's a bit, at least as per me, it's very roundabout. So I think if we can calculate the substitution effect, then we can calculate the income effect also. So I'm just trying to draw a diagram to explain it. Okay, I'll come back to this. So actually, the question which I wanted to discuss is going to answer all of these questions, I think, a whole lot better. So let me just go to the question which I have, and then we can solve this question. It will take only 2 minutes, and then you can see if you understand it better or not. Because this one is a simpler question. The one which I wanted to take is a slightly more complex question. Is that okay? I'll just explain the concept to you first with the question which I brought with me. That will go into it in a lot more detail. Okay. And then we can come back to this. Okay. So let me just share the question. Let's just start with the question itself. Right. So this is the question. It is a slightly different question, not exactly the same as what you have, but the functions and all are slightly different. So in this, let's first look at this. So we are given that we have a utility function. It's what kind of a function is this? Any guesses? The type of function we have taken here, the utility function. Does anybody know the know the name for it? So it's the Cobb-Douglas function,
E Cobb
right?
Douglas, yes.
Yeah. So this is the Cobb-Douglas function, and you can see that this is one of the simpler examples. Now here, this is a question which is I've taken it from Perloff. It's a partially solved example in Perloff because they've not shown the whole working for all the steps. They've just given the answer. But either way, it is an interesting question. So here we have defined the consumer's utility in terms of live music and in terms of other soundtracks. Okay, so M is live music, T is other soundtracks, and we know prices of both, and we know her income. So first of all, like we will come to utility maximization and all that. So first of all, the first part is how do you derive the demand function for T and M? That is the first thing that is asked. So I'll just give you, and when we say demand, we mean by default, if nothing else is mentioned, we're asking for the Marshallian demand, right? So I'll just give you 1 minute or a few seconds at least to just think over it, and then we'll discuss. And if you solve it, you can just post the answer on chat box. Okay, let me see if anybody has. No, I didn't ask you for the values. I asked you for the function. So we will come to that is part B where you solve for the optimal consumption bundle. I'm asking part A first to derive the demand functions for T and M. We studied this, right? I think we've studied this. We first derive yeah, I think Professor Vimal discussed this in the lectures. We first derive the demand functions for X1 and X2. In this case, you have T and M. And using that, of course, afterwards, you can find the optimal consumption bundle also. Okay, so I hope you got, no, you have derived what? I'm, I'm asking you for the, what do you call it? Demand function. I'm not sure which function you have shared with me. This does not look like a demand function. I think you are giving a different version of the utility function. Okay, it's okay. We'll discuss it now. So what we do in these situations, I will come back to this. So let me erase this because it'll not make sense here. Okay, let's go to question 1. We are given u is equal to t to the power of 0.4, m to the power of 0.6. Here m is a variable, it's not income. So I'm sorry if you are confused from what we discussed. And we are given the income y, and we have y is equal to, you can take pt into t as price and pm into m. So pt and pm are the prices. So you can assume any name for the variable you want. I've just taken it as pt and pm. What we have to derive is the demand function. Okay, so it's not very difficult. Instead of finding that optimized or optimal bundle, you just have to derive it in the form of a function. So what we do normally is ux upon uy is equal to px by py, right? So you have something like this from the MRS discussion. I hope everyone remembers this. This is what you do, right? Now, in this, we calculate the values of ux and uy, and we just put px and py as, uh, whatever, pm, pt, and then we move forward from there. Okay, so first of all, let's see ux, or there's no x here, so okay, and um, all right, and from here, what you get? Okay, so this 0.6 plus zero point 0.4 becomes 1, right? And you can cancel out a few things. So 0.4, 0.6, you will just get 2 by 3, and m by t becomes m by t. So if you want to simplify it, you can, in later stages, you can put in the values of pt and pm. Otherwise, you can just write 3t by 2. Now we know the budget equation, which is 2, y is equal to p t into t plus pm into m. This gets cancelled. Pt into t, you have what? Y is equal to 5 tpt by 2. Is that so? Right? Okay. T is equal to 2y by 5, which can further simplify as 0.4. Okay, this is how you solve it. This is how you normally solve it also, right? For optimization. But in optimization, you just plug in all the values. This is a little bit more of, algebra. So it looks a little bit unfamiliar terrain. It looks a bit scary, but it's not that scary. So is this, let me see if this is the answer. Yeah. So this is what you get. Now, similarly, you can just solve for m. M we know is what? 3t by 2. M is equal to 3t by 2 into pt by pm. So this is point, or we can just go back to the simple stuff only. Okay, and this is your m. So you can write t comma m is equal to 0.6. Oh, sorry. So this is how you solve for the Marshallian demand. Any problem? Is this okay with everybody? No? Yes? Anything you didn't understand? Just zoom out and go back to the whole thing. So let me just recap what we did. It's nothing very complicated. It's the usual thing we did. We've done it for 2-3 weeks now. We did we took the basic identity from the whole, the MRS discussion, where we know that the ratio of marginal utilities comes out to be equal to the ratio of prices at the point of tangency, right? This is at the point of tangency. It's not always true, but at the point of tangency, which means at the optimized level, this is going to hold true. Why? Because ux by uy is the slope of the which curve? Indifference curve, right? And px by py is the slope of the budget line or the budget curve. And at that point of tangency, both the slopes have to be equal. Right now, ut and I've just taken the first order partial derivatives. So this is ut is basically equal to del u by del t. I hope this much is not this is not confusing. This is just the basic mathematical notation normally used. So ut, u subscript t, u subscript m are the first order derivatives, partial derivatives of u with respect to t and m. We take the first order partial derivatives and then we plug in those values back into that identity, not identity, but that equality, MRS equal to price ratios. And here we just put in these values and we just do a little bit of rearrangement, a little bit of algebra, a little bit of arithmetic. M by T here is 0.6. Here M by T is 0.6, the exponent, and here it is minus 0.4 in the denominator. So if it is minus 0.4 in the denominator, you can take it to the numerator, it will become 0.4. And if m by t 0.6 into m by t 0.4 becomes m by t to the power of 0.6 plus 0.4, which is 1. So what we get here is 2 by 3 into m by t equal to pt by pm. And then we just, the ratio of the two variables. You sort of just do a little algebra, you rearrange it, and you plug this back into the budget constraint. This is your budget constraint, right? Y is equal to pt into t plus pm into m. Instead of m, we plug in this value, which we just arrived at. Then we, of course, simplify it a little bit. Pt into t is common in both the terms. We take that common. 3 by 2 plus 1 becomes 5 by 2. And This is how you get y is equal to 5t into pt by 2. You just rearrange it a little bit. This is the final expression you get. And you plug this back into the expression for m. M was what? 3t by 2 into pt by pm. You simplify it and you get the final answer as this. So this is how you derive the demand vector or demand curve. Is this clear? So this is the Marshallian demand. Why? Because we have taken budget as constraint and we are doing the whole exercise of maximizing utility. So by default, whatever we have been doing so far, where we take budget as constraint, we automatically call it as a constraint only. So whenever you take budget as constraint and not the objective function. The objective function is the expression which you're trying to maximize or minimize. This is the basic language of optimization, where there is one constraint, or maybe one or more constraints. There is one um, objective function, and then of course you know which variables are to be, which are the variables which you can choose, choice variables, and then you optimize over that. So in this case, utility is the objective function and constraint is the budget equation, right? So that is why this is Marshallian. If it was the other way around, where we take budget as the main objective function and utility as the constraint, then it becomes Hicksian. Is that okay? Is this part clear at least? Okay, let's move on to the next part. So now next part is pretty easy, the optimal bundle. From here, you can just plug in the values of, let me look at the question, of PT, PM, Y, everything. So initial optimal bundle is equal to 0.4 into what is sorry, Y is 30. PT is 0.5. So this is 16 to 0.4, just 24. And sorry, I have written it the other way around. M star, you can calculate either from here or so your optimal bundle is 18 comma 24, as you got. I think you got that answer, right? So that's correct. Okay. So next we want to know the effect of an increase in price. Okay, which is what basically substitution and income effects are all about. So see, whenever prices, even if prices are increasing, if both the prices increase in the same proportion, then what happens? There is no change in the slope of the budget line. So we don't really have to worry too much. I mean, of course, there'll be changes, but the whole mechanics of the problem does not change. The mechanics of the problem remains pretty much the same, right? It's equivalent to just a simple shift, right? But in the case when your prices change, either one price changes only, or both the prices change but in a different proportion, then in that case uh, we have to think about the rotation of the whole line itself. Yeah, so let me draw this diagram. This is kind of an important diagram. If you understand this, hopefully you will understand all of income and substitution effect. So just out of curiosity, has everyone already properly understood income and substitution effects? So I will not spend that much time on it if you have, which is why I'm asking. So this is the initial budget line, right? Just trying to make sure I don't get the curve wrong, that's all. Okay. And after shifting, uh, okay, you can just assume it's a straight line. Okay, this is the initial optimal bundle. And okay, let's assume this is the point of tangency. It's not exactly touching, but okay, let's try this again. So the thing with this diagram is that it cannot be drawn just, arbitrarily like that. Arbitrarily things go wrong. So I know it's a slightly shaky line, but I don't have enough elbow room here to draw it properly. So this will have to do. So this is, say, suppose E1, let's call it E1. Trying to use the same naming as is there in the book. If you want to sort of refer back to it and see what we have discussed. So there is a little bit of explanation in the book if you want to check that out. Okay, now this is, I think, hopefully a bit self-explanatory. The original green line is the original budget curve. We can take this as 60 and 30. This is 30. Though it's not germane to the problem, but this helps put things in perspective. So the original green is the the original budget curve. The pink is the shifted budget curve. So the price of tea doubles, right? So that means what? Now she can buy fewer soundtracks for the same amount of money, right? So if you take the corner solution, then corner solution will be 30 now instead of 60. So now these two are both on a different indifference curve. So this, let me put this is equal to I1. Say this is I1. This is I2. So I1 and I2 are two separate indifferent curves, both having a different level of utility. Now, what we want to do is we want to basically draw this line parallel to this line. It's fine, but okay. So this dotted line which I have drawn, it's dotted because it's not a real line. You can call this E prime or E star, whatever. I'm erasing this 30 for now because it looks as if 30 is the value of the thing, which it's not. So just don't mind that. It's not 30, the original E1, as we already know it, and it's not more than 30 also, but I'm just showing this for representative purposes. Okay, all these curves are going to be a little more to the left, but now it's gotten drawn this way, nothing can be done. So I'm just erasing these values because otherwise you will get confused about the values if you start matching it. If you really want an accurate diagram, you can see it's in the book if you would like to refer to it. But otherwise, for now, just for explanation purposes, this will have to do, right? So now substitution effect is what? This is the important part. If you understand substitution effect, you will understand income effect also. Substitution effect is when we hold utility constant. Okay. The overall effect is the overall effect of, this budget line is like this, it rotates to like this, and then the tangency point is also different. Everything has changed. You move from one budget line to a different budget line, you move from one indifference curve to another indifference curve. Right? That is what is happening in totality. What we are trying to do is we are trying to break it up into two small parts, right? Now, the first part of this shift is where we are saying what if we don't actually for the moment we forget about the income and prices or whatever. We just assume that this particular shift, we are making this shift while holding the utility constant. So if you're keeping utility constant, it means you're moving along an indifference curve. What we are doing is we're looking at the Hicksian demand. And that is what we have is substitution effect. So what Hicksian demand looks at is that if you're moving along a utility curve, right, then in that case, there is going to be some other point of tangency. Now, we are saying that the price ratio is the same, but let's assume that the consumer has been given some extra income, they have been compensated so that they're able to maintain the same level of utility. Because even when the prices are increasing, obviously the person's opportunity set or budget set, whichever way you want to call it, is decreasing, right? So this whole part is lost. You see this part, this whole triangle, this whole triangle is lost for the consumer. Let me switch it back so you don't get confused. Now, I just shaded it so you understand what is actually happening, right? Now, this whole shift, when you rotate that green line from given prices to new prices, it rotates, right? One price is changed. Now, after that rotation, a big part of that opportunity set is lost to the consumer. But what we are saying in Hicksian demand is that that lost part, say suppose we compensate the consumer for it, which is why it's called a compensated demand. Say suppose we compensate the person, the consumer, and we want to force that consumer to hold the same level of utility even after the price change. That is obviously not possible given the conditions. So we give them extra income, which is why it is equivalent to shifting of the budget curve outside. See, so what we're doing here is it's equivalent to a outward shift of the budget line. The dotted mauve color or lilac color line is nothing but the shifted version of the solid pink line. Is everybody getting this? I just wanted to know if you're actually getting this. If you're not, I'll explain more. Otherwise, I'll stop here. Is it making sense? Then what happens at that point of tangency where the shifted budget line actually it becomes tangent to the same indifference curve. If you take that point and you see the difference between the original uh, optimal bundle and this new optimal bundle, this is called the substitution effect. Is this clear, or is it still very confusing? Okay, there are no answers. I have no idea whether you've understood or not, but I think I have explained it. So, and if you see the whole change, this whole change, not the other way. This whole thing is the total effect. And the remaining part here is the income effect. Is this clear? So if we want to find out income effect, we can just find out the substitution effect. We can find out the total effect, and we can just take the difference. So total effect we can find out by just finding the new optimal bundle. So initial prices and budget and everything is given to us. Initial optimal bundle also we know. We can just find what is the new optimal bundle with the new prices. That is and the change is happening in which variable? In T. So we just see the change in quantity of T. That will give us the total effect, the total change. Then what we do? We have to find the substitution effect, right? So substitution effect, what we do is we find the initial level of utility given the initial variables. So you have the initial value of optimal values, right? We calculated 24 and 18 initial optimal values. So let's say initial U bar is what? T to the power of 0.4, right? M to the power of 0.6, isn't it? Let me see. Yes, and our values were 24 and 18. So somebody can use a calculator and please calculate this. 24. Can calculate initial utility level, U bar. Okay. And from here, the initial utility level. Now we have a new equation for the optimal thing. Say suppose the new compensated budget is say Y bar. Okay. In this dotted line we're talking about. What we want to know is what is the what would have been the shift if we were taking the compensated demand, if we were looking at the point E star instead of E2. So what is utility level you're telling me? Okay, so just keep it with you. So Y bar is equal to, or Y prime is equal to PT prime into T plus PM into M, right? Sorry, my handwriting is becoming a bit. Okay, PT prime is the new price and Y prime is the new budget, whatever we compensate it as. Now, let me just see if there is, I have the answer solved somewhere. Okay, I do have it. Yeah, basically what you do is you solve for this now. You know yeah, you can solve for this. We know PT prime, we know PM, and we take the initial condition which we had taken, right? We take UT by UM is equal to PT by PM. You calculate this value, you will arrive at, a similar result. Here PT and PM are changed, right? PT prime, sorry, not PT. So in this, you can simplify this value, see what you get, because this part is still going to come out to be 2 by 3 M by T, right? And PT and PM are 1 and 1 now. It changes to 1 and 1. So any questions? I hear somebody talking. Did anyone want to ask a question? Okay, I've muted you. If you wanted to ask anything, you can just unmute and tell me. Okay. Now I'm just making sure I've not made a mistake. Yeah, so you know the value of M, you know the value of the prices. I plugged all that in. Now what you do is you put all these things back into the equation and you solve for it, right? This I solved, and then what did we get? Yeah, you solve for T from here. What you know is U bar is equal to the, now we're holding utility constant, right? So it's T to the 0.4, M to the 0.6. You put in both these values. T is 0.4, M is 3T by 2 to the 0.6. Okay, so this is 3 by 2 T, right? U bar we know. Calculate this value 3 by 2 to the power of 0.6. T from here you can calculate the value of T, new value of T. Please calculate and see what it comes out to be. Now, whatever this comes out to be, this is the value you would get based on only the substitution effect. So the difference between this value and the original optimal bundle gives you the substitution effect. Okay, so say suppose we call this as something else, t star s. Okay, so this value comes out to be, has anyone calculated? I think it comes out to be something approximately 16, not exactly 16. This comes out to be 16. So then your substitution effect is basically equal to t star s minus t star, right? 16 minus 24 is equal to minus 8. And the new optimal values, t star, I don't know what do you call it, and let's call it new. I think it comes out to be 12. You can calculate and see again. I'm not doing the whole calculation because it's almost 7 and I don't want to take up the whole class in this. But if we are not done with producer theory, I'll extend the class. Please don't worry about it. I know you wanted to study producer theory, but this part was kind of important. I didn't want to leave it unfinished like that. Okay. So then what do we know? Total effect is equal to income effect plus substitution effect minus 12 is equal to income effect minus 8. Is this clear? I just went over a little bit fast in the last part, but it's just calculations. I've not mentioned anything new. I've just tried to go over the calculation a bit faster. Any problem? Did everybody else try solving it? Did you get a different answer? Different answer, same answer, not convinced about the answer? Please say something, whether you have understood it or not. Because I mean, I can try, but if you tell me what is wrong, I can answer. Otherwise, I will move on. You will watch it again? No, 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 don't. You okay? You can watch it again also, but just tell me where you are hazy. I know I went over it slightly fast, but I can repeat a little bit if you want. It's okay. The purpose of this class is not to cover everything, but to at least help you understand whatever you have not understood, because all the lectures are already there. I'm taking these up because I was not convinced that everybody has understood it, not because I need to cover the syllabus. And the silence kind of proves my point. So graph you understood, okay? Then what part did you not understand? You can just unmute and speak if you want.
So I understood the graph and the theory behind it and how
Okay,
income effect is calculated. I said
okay,
for this problem I'll go over it again and do it
okay,
once more.
okay. So I will just give you a 1 minute recap of what I've done in case I went a bit fast. So initially we calculated the demand vectors first, then we calculated the initial optimal bundle. We know the initial optimal bundle now, right? T star, M star. For those values of T star, M star, we found the utility level. We calculated it over here, whatever this value comes out to be. Okay. Now, this utility level is corresponding to this indifference curve. Indifference curve means what? The utility is constant on it. So we wanted to find that particular value on that curve. Now, first we are finding the substitution effect, because substitution effect is easier to calculate, because in income effect, you have to first find this point E star. And to find this point E star, you anyways have to calculate the substitution effect, because it is an imaginary point, right? What you have calculated so far or easy to calculate is E1 and E2, initial and final optimal bundles. But to calculate the decomposition of income effect and substitution effect, you need to know E star, right? How will you calculate otherwise? So what we are trying to do is find that point E star. That is the whole objective of this whole exercise. Now the rest is basically just algebra. Actually, there's There's nothing, I've not done anything new. I followed the same method which we used before. So E1 was the initial optimal bundle. We calculated the new optimal bundle E2. I've not shown the working for that because I hope you can solve it on your own. I went over it a little bit fast here. So this whole part I did here. All this, I went over it a bit fast. But E2, you can calculate once on your own and see what you get the values as. You should get the value I have given in the end. I've just not shown the working for that, but I've just told you that E2 comes out to be 12 for T. T is T star at E2 is 12. For E star, this point, or let's call this some other point if E star is becoming confusing. ES or EC, let's call it EC, the compensated demand. Okay, at EC, we are doing this whole working. Now, you know the original U bar, original utility level. We have the new prices. We have the original utility level. We don't know the new income. And we don't actually need to calculate it unless it's asked in the question. What we do is we write the same equations. We solve using the marginal utility and price ratio as usual. We get a value for M in terms of T here, and we plug that value back into this whole equation of U bar. U bar is equal to T to the 0.4 and M to the 0.6. We just replace the value of M from here into here, and it's an equation, linear equation in T now. U bar we know, T we can calculate from here. That's all we wanted in the end, right? That was the objective. So substitution effect is what? The new value, which is Ts star minus original value, which is T star. The 16 minus 24 equal to minus 8. And the final at E2, the final value of Tn star comes out to be 12. So the total effect is 12 minus 24 is minus 12. Minus, I'm putting everywhere minus because it is decreasing, right? It's not increasing, it's decreasing. So from here, you can calculate the income effect, which is total effect minus substitution effect equal to minus 4. Okay, I've given a decent recap, I think, and the methodology remains the same. Hopefully, they are not going to ask you more difficult questions, but if they do, we will, I don't think they'll ask you more difficult questions than this. So any questions now? Now in the assignment which you mentioned, you can now calculate it, right? The question number 6, we can calculate the indirect utility function. You can solve for it in terms of M and P. And 8, the income effect. You can now calculate the income effect, right? You can from here, after calculating P star and M star, you can calculate the new value of Y prime from here, right? From this equation. Once you solve for, I've not solved for everything, but after solving for T star and M star, you can solve for this value of Y prime. I didn't solve it because in my question it was not asked, but using a similar methodology, you can solve for the new value of I prime, which is the compensated income. Okay. And question number 10 is, does substitution effect of fall in price of bananas impact consumption of apples? So again, you can calculate, then once you calculate the new consumption bundle, optimal bundle, you can see if only T is changing or M is changing. Like in this question, if only apples are changing or bananas are also changing, and you will see that both are changing basically. Okay, so I think this one was a slightly more complicated question because the utility function was Cobb-Douglas. There it's all linear equations, and mostly I think it's going to be corner solutions, right? Because it is a case of substitutes. No, it's not substitutes, it's x1, x2 only. But it's a little bit simpler because there's no complicated powers. So we can solve the same thing. Okay, so if it helps, I will solve this assignment question and I will post the solution in, you'll have to give me by end of day or tomorrow to do that. Because I think we've taken 1 hour for this. I just wanted to explain the concept a bit better. Okay, all right. Any other doubts? Otherwise, we'll take a 5-10 minute break and then we will come back and we will do producer theory. So let me share the question in the meantime. Yes. So I will be back in a few minutes. In the meantime, this is actually, let's go to this. Okay. We will come to question 2, but in the meantime, you can solve question number 3 if you want. Okay, I'll be back. Okay, so let's start with producer theory. Let's go to question two. So, what do you think? Um, for question two, which one do you think is? Um, you can type in your answer in the chat box. Which axiom do you think is uh, not not an axiom of production technology? So there are several axioms we study in different parts of consumer and producer theory, right? So in this one, which one do you think it is? Which is not an axiom of producer technology? Nobody? Why? Nobody has answered? Okay. So what is no free lunch? What do we mean by no free lunch? It means you can't produce with zero zero inputs. You can't make something out of nothing. That is kind of what is, you can say, like a very simple version of no free lunch. Non-reversibility is what? Like after you have taken milk and tea and sugar and heated the water or whatever and basically boiled it and made tea, you cannot get you cannot get tea leaves and sugar and milk back from it. You can't reverse the process of production is an irreversible process, right? Does everyone agree? Any problems with these things? I'm just giving a very simple, layman kind of understanding of the axioms, right? Yes, yes, no, maybe, don't agree, disagree, something. I just want to know if I'm making sense. So that is non-reversibility. So that will be an axiom of production technology, right? Completeness, let's come back to that. Convexity is when if you know of the whole output set, then any linear combination of any two output quantities is also going to be a part of the production set. It's also going to be a part of the output vector. Is that okay? So that convexity also we can agree that it is mostly, um, you know, it is mostly true. Completeness is an axiom of what do you call it? What would be studying till now? Consumer theory, preferences. Sorry. So completeness is an axiom for preferences, for defining utility function. But in this particular case, there are no preferences per se. We don't have to do any kind of ranking because in this case, as you will see, we are not optimizing something like utility. We are optimizing for a profit, either profit maximization or cost minimization, whichever way you look at it. So it is not a question of preferences. It's basically a very, it's an empirical thing. It's a very clear, they're just numbers. So you don't need to kind of, worry about ranking them or specifying a relation for them. So, I mean, you can say that in the world of real numbers, completeness is already satisfied. That is true, but it is not a required axiom for production technology. Okay. So completeness is the one which is not an axiom related to technology. Okay, let's come to question number 3. So what is average product of labor? Let me stop screen sharing from here. Yeah. So what is exactly average product of labor? Average product of labor is, sorry, I'm just connecting my iPad so I can share. Okay, average product of labor is equal to output by sorry, quantity divided by labor, right? So is given, Q is given as Pop Douglas to us. Q is equal to 25 K to the power of 1 by 3, L to the power of 2 by 3. So average product of labor becomes 25 K to the 1 by 3, L to the 2 by 3, 3, 3 divided by L. So 25 K to the 1 by 3 doesn't change, right? L to the 2 by 3 minus 1. So 2 by 3 minus 1 is what? Minus 1 by 3, right? Only one person answered this, which is what is a little more troubling. What happened to everybody else? Just lost interest or not following the discussion? Okay, we will come back to that problem of people not answering in the class later. But let's continue for now. So what is short run marginal product of labor? Okay, this is just a conceptual question. So I hope people can answer. I'll give you a second to think. Okay, one person has answered at least. At least different people are answering. I think I should be happy about that. Others? No? Okay, so what do we do in marginal product of labor? In short run, what is fixed? We fix capital, right? In short run, capital is fixed. Why is capital fixed? Because it's very difficult to change capital in a short time. Like if you have a huge machinery, if you have a lot of property, if you have a lot of, you know, equipment, raw materials. Raw materials actually not exactly capital, but okay, in economic sense, it is capital only. So it is, raw material won't be capital. Raw material you can think of as inputs actually. So capital would be like all machinery, all property, all of that is capital. So it's not so easy to just do away with it or to just buy a new, buy a new factory or something, right? So it doesn't work like that. So, which is why in the short run, when we say short run, it's not a fixed time period. It could be 6 months, it could be 1 year, it could be 5 years. It depends, right? Generally, short run is not predefined, but in for different economic variables, people take a different time period as short run, and um, they mention what time period they're taking as short run. So in that much time, it's generally like if you say suppose 6 months, 1 year, generally the capital does not change much, right? Or you can assume it as fixed. So in the short run, capital is fixed. So if your Q is f of k comma L, then k is already fixed, right? So this is nothing but sort of similar to just Q being just a function of L. Some other function, small f I've used because it's not the exact same function. It basically becomes almost the same as this. Now, if you take dq, or not dq actually, if you take ks fixed, then it will become dq only, but still, let's go by the proper things. if you take del Q by del L, what is that? Change in quantity for one change in, for one unit change in input, labor input, right? So this is your marginal product of labor. APL we saw was, remember, remember APL is Q by L. Here MPL is del Q by del L, right? So del Q by del L means what? Change in output for unit change in labor input, which is what the question is basically asking you. It's just worded in a slightly confusing way, but the question is asking you just the basic definition of um, marginal product of labor, which is what? The change in output per unit change in labor, holding capital fixed. This first one is the correct one. And the others are just some, funny or confusing wording just to test if you have actually understood what is marginal product of labor or not. Okay, so let's come to this or question 5. So, what are perfectly substitutable goods? What are perfect substitutes? Where you can substitute one for the other, meaning there is some sort of a linear combination of the two goods. That is what it means. So, I'll come to a more elaborate definition in a little bit of time. But first, I wanted you to attempt the question yourself first before I explain anything. So, which production functions here do you think is an example of substitutable goods? So, I'll give you a minute to think. One person has answered. What about the others? Okay, so let's go back here. Okay, so what we mean by substitutable goods, substitutable, sorry, in substitutable inputs is that Q is a function of K plus L, or you can say not even K plus L, since we are not saying they are substituted in the same proportion. F of means function of. You understand this better as this, then you can say F of this. This is not F into this. That's all I'm trying to say. This is a function of this kind of a thing. Well, you will understand why I'm saying this in just a moment. So, of course, what would be an example? AK plus BL is obviously substitutable, right? A and B can be anything. A can also be equal to B, may not be equal to B. So A can be 1, B can be 2, 3, 4.5, 102, whatever, right? Q is equal to AK plus BL. Whole square will also be substitutable, right? The whole thing is square. F of means what? This here, F can be anything. F can be Y is equal to X square. Oops, why am I writing so horribly? F can be Y is equal to X square, Y is equal to under root X, Y is equal to log of X. so on and so forth, right? If you have something like Q is equal to ln AK plus BL, that is also substitutable. Is this making sense? All I'm saying is that as long as you're using a linear combination of inputs, then any function of that, if your output is a function of a linear combination of inputs, which is K and L, then then the inputs are always substitutable. Meaning what? You can substitute L for K and K for L very easily. If it is something like a Cobb Douglas, K plus L, K into L, then it is not a case of substitutable goods. Okay. So somebody said that this is also substitutable. Now, this is not a linear combination of K and L. Why is that? Root K plus root L are not the same thing as K plus L, right? It's a different power. You can't equate this to, this is not a linear combination. This is not a linear equation. Okay, this is exponent of half. If it was Q is equal to under root K plus L, then yes, it would be. This is not a linear combination. If it is under root of the whole thing, K plus L, then yes, that's a that's a linear combination. Under root K plus under root L is not a linear combination, right? You understand why that will not be? The person who answered, I think you had answered that, right? Okay, let's go back to the question. So in this question, the first one, A root L plus root K is not a linear combination, right? Then Q is equal to under root KL is also not a linear combination. C, Q is equal to root of K plus L. That is a linear combination, right? Which is, and here F is what? Square root function. So F is, so you can write this Q is equal to under root K plus L as F of K plus L, or F of AK plus BL, or whichever way you want to write it. D is what? F 4K plus L. There is also a combination, right? It just means A is equal to 4 and B is equal to 1. So Q is equal to 4K plus L. E is minimum of K plus L. Now, this type of function is never a case of substitutable goods. And why is that? Because this is a function representing complementary, I don't know why I keep calling it good, sorry. This is a case of complementing inputs. They are not substitutes at all. These are actually complements. So Q is equal to minimum of K and L means what? Production can happen only if equal quantities of K and L are available. You cannot substitute one for the other. Okay, now we come to a different question with almost the same kind of, options. So in this equation, in this question, which equations do you think represent a production function which has constant returns to scale? I'll give you a minute to work this out. You can solve and see which ones they are. Then we'll discuss. Please post your answer in the chat. Okay, anybody else? Just giving you a moment to work it out. Okay, so I think a lot of people are having a little bit of trouble. So, is there any question you have in this part of producer theory, which we have sort of covered so far? You have a question, please tell me as well, so that I understand where you are stuck. Or is it, has everybody actually gone through the whole content for week 8? Is there anyone who has not done the not gone through the lectures for week 8 so far? Has everyone gone through all the lectures for week 8 so far? Yes, no? You can just raise your hand. Okay, I don't know what that means. So, is there anyone who has not gone through week 8 content at all so far? It's okay if you haven't. I just wanted to know if you have or not. So I will sort of explain accordingly. Okay, so seems everybody has gone through it. Okay, I started writing again in the wrong way, but well, nothing can be done now. Okay, so what do we mean by constant returns to scale in the first place? So if say suppose Q is equal to f of k comma L, and what we do is we introduce uh, you know we scale both the factors of production by theta, say suppose. Okay, so then if Q prime is equal to f of theta k with and theta L, I'm just saying theta, you can take any number you like, is equal to theta times is equal to theta times Q, then we call it as constant returns to scale, which means that if f of you can say Q of theta k comma theta L is equal to theta times, oh my god, I'm writing theta and Q in a similar way. Theta times Q of k L, then it is constant returns to scale. That is the way you find out. Okay, this is the basic value. Now um if it is not, if it is, if say suppose Q prime you get is this, if Q prime is equal to f of theta k comma theta L is greater than theta times Q, which is what, f of kl, then it is increasing returns to scale. And conversely, if Q prime is less than theta times Q, then it is decreasing. Equality is constant. So if you're, I'm just giving you the mathematical, the mathematical explanation for returns to scale. But basically, what we are trying to say in returns to scale is that, if you're scaling the inputs, okay, you're saying, say, suppose I take, 1 cup of milk and 1 teaspoon of sugar and 1 teaspoon of tea leaves to make tea, and I double all of it. Okay, I take twice the amount of milk, which is that I take 2 cups of milk, and I take um, 2 spoons of tea leaves and 2 spoons of sugar, then I should in the end get 2 cups of tea, right? That if that is true, right? If doubling the inputs gives you exactly double the output. I'm saying double because that is easier to think, intuitively rather than something like theta. Right? Theta, we can't visualize that easily. Double, you can visualize more easily, I hope. So if you're doubling the inputs, you should get double the output. If that is happening, then it is constant returns to scale, right? But sometimes what can happen is that you double the inputs, but you get more than double the output, right? Meaning, and say not T maybe, like, but if there is something like, there may be some production process. Generally, these kind of production processes don't are not that common. But if there is some production process in which you're doubling the inputs, so suppose there are 3 inputs, A, B, C, and you double each input, 2A, 2B, 2C, but in the end, you get more than double the initial output. So if your output was Q with A, B, C input, and you get output something like 3Q after doing 2B, 2A, 2C, then it is increasing returns to scale. And the converse, like if you double the inputs but you get less than double the output, then that is decreasing returns to scale, right? Is this much clear to everybody? What is exactly returns to scale? Any problem? Now the mathematical identity, or the not identity, but the mathematical method at least, of finding out whether any given production function is following increasing or constant or decreasing returns to scale is this. You multiply each factor of production by some value, maybe theta. I've taken theta as a general number. You can take alpha, you can take anything else, you can take lambda, whatever you like. If you don't like Greek, you can take something else. If you multiply each input by say theta, then what is the impact on output? So is output theta times q, or is it more than theta times q, or is it less than theta times q, or is it sort of just indeterminate? You can't exactly arrive at a conclusion also. So let's check. Okay, let's go to each expression one by one. So now let me annotate in this in itself. So in this, say suppose Q is initially this root L plus root K. And what happens? We multiply both Q prime is equal to under root 2L plus under root 2K. What you get is under root 2 into root L plus root K. This is why I don't write it on this. This is the annotating part is not very nice. So what is this? Q prime is equal to root 2 times q. Root 2 is less than 2. I hope everybody will agree. So this is decreasing returns to scale. And with this, I think I will annotate the rest of it uh, in one note, because this is kind of annoying, frankly. Q is equal to under root KL. Let's go to this. Q is equal to under root KL. Now, if I multiply both K and L by say 2, so you get under root 2K into 2L is equal to 2 under root KL is equal to 2Q. Right? So this is constant returns to scale. Yes. Part B. C is Q is equal to 4K plus L. Okay. Q prime is equal to 4 into 2K plus 2L. You can take 2 common. What do you get? 4K plus L is equal to is equal to 2Q. So Q prime is equal to 2Q. Therefore, it is showing constant returns to scale. Next. So sometimes, you may think intuitively this will be constant or this will not be constant, but sometimes, our intuition is not usually as sharp as we always believe it to be. Sometimes the intuition makes what do we call it, calculation mistakes, right? Which is, I think, why initially you said that root k plus root l will be constant returns to scale, and then you change the answer. So sometimes it is easy to make a very simple calculation mistake just by looking at the function. Mostly you will be able to tell just by looking at the function, but if you have, if you're in a test or an exam or something like that, it's just risk free to calculate it yourself instead of just calculating based on looking at the function. So what do you get? 2k plus 4 times 2l. You take 2 common again. Therefore, this is also showing constant returns to scale. So far we have B, C, and D. What about E? Q is equal to minimum of K, comma, L. Now in this, Q prime is equal to minimum of 2K, comma, 2L, which is equal to, you can take 2 common outside again, right? Is equal to, so in this case, you're seeing even in the case of perfect complements, this is actually showing constant returns to scale. Which one was not showing? Okay, I haven't written down the one which was not showing. Let me write that down also. I wrote it in the other thing actually. So this is not showing constant returns to scale. This is showing decreasing returns to scale. Okay, so is this clear? Any questions, doubts, anything?
Mhm.
Problems?
Hello,
Yes.
ma'am. Can you give an example like this only, showing increasing return of scale?
Yeah, I know that is a good question. The thing is that in most of actual, if you study a little more producer theory, we will not usually be working with examples of increasing returns to scale. Usually we will not have those kind of a thing because, see, if something is showing increasing returns to scale, it is generally required to be sort of bound from above. Otherwise, it's like, you can increase inputs, you can go on increasing inputs and output will go on increasing until it becomes infinity, right? Which is why even the increasing returns to scale usually happens only in a certain window. Like it doesn't happen as unbounded increase. You getting me? So if there were a function, say suppose, um, so if you have something like q is equal to k square l square, or you can just say k l whole square, then q prime is equal to 2k into 2l whole square is equal to 4 square is what? 16, or you can just keep it as, yeah, actually I'm not wrong. So 16 into kl whole square is equal to 16 times q, right? So then in this case, q prime is equal to 16 q, which is increasing returns to scale, right? But in real life, I'm just saying, this is hypothetically speaking, this is an example of a production function. But in real life, or even real life as in the real life of economics, if you study further, you will very rarely use a function of this type, because this implies that if after a certain point, this output can be infinite, right? With finite resources, which does not, because see, from this kl whole square, just by doubling the inputs, what we got is 16 times the 16 times the initial output, right? So this function can just basically blow up into infinity very quickly. If you do this 10 times each, you get 10,000 times the initial output, right? You're just increasing the inputs only 10 times each, but your output you're getting is 10,000 times of what you would have got initially. So you can see this function is basically uh, going to become infinity very quickly. And in mathematical terms, infinity is not a defined number. It just means it's a number which we don't want to deal with. It's too big for us to deal with, or it's undefined. Undefined, but very big. So, which is why, and that's not realistic. No firm experiences increasing returns to scale in that way. So, usually, even when they have increasing returns to scale, it will be maybe 1.2, 1.5, something like that. Not like, and that is also, I'm just saying that if at all, and that will also be in a certain window, not like for any value of input, but for a certain window of inputs, you will get maybe increasing returns to scale for of that sort, greater than one, basically. So uh, that is a good question. Um, so you otherwise, like if you just want to know theoretically speaking, theoretically, this kind of a function, any function which has uh, which is k and l are in um, exponent is more than one, something like that, you will get like you will get increasing returns to scale just by looking at it. Even if it is q is equal to kl, oops, even if it is q is equal to kl, q prime is what? 2k into 2l is equal to 4 times kl is equal to 4 times q. Even this is increasing returns to scale. So that is why we have this Cobb-Douglas function actually, because in Cobb-Douglas, the sum of powers of this, if you have, instead, if you have something like q is equal to k to the alpha in L to the beta, alpha plus beta is equal to 1 usually. I mean, of course, you can have functions where it is not 1, but for Cobb-Douglas, usually we take this as alpha plus beta equal to 1. And in that case, we will come to that example or a similar example. I don't want to solve it because I think it is there in your assignment. But in that kind of a case, we see constant returns to scale. We wanted to find, like Cobb-Douglas function basically solves that problem where the two inputs are in multiplicative sense, like being used in a multiplicative sense, not in as substitutes or complements. So, but without showing increasing returns to scale. So then if you impose this condition, you don't get increasing returns to scale, as you will probably solve and see. Okay, any other question? No? Okay, so let's move to the next question, which is exactly what she was asking. I have not taken the function, that k to the alpha, b to the beta, l to the beta, because I think that is in your assignment, but we will do a similar kind of a question, which will hopefully help you with your assignment. So I'm just going to mute myself for 2 minutes. Please solve the question and tell me what you find out. Any takers? Nobody solved it? Come on, we just discussed it. All you have to do is multiply L and K by some value. If you want to multiply by 2, you can multiply by 2. If you want to multiply by theta, you can multiply by theta. So let's, this is question number 7. Okay, so we are given the function as L plus L to the alpha, K to the beta plus K. Okay, let me shift this down. It's getting all merged with previous. Okay, so now let's calculate Q prime, in which we are multiplying each input by, let's say, theta. Okay, it's a more general thing, so I like it if, I mean, I feel like, I might cancel out some 2 somewhere, or something might, not be so clear, so I prefer to use theta. So let's multiply each factor by theta. So this is what we'll get. So far so good. Okay, so Q prime is equal to, again, let's say theta L, theta to the power of alpha plus beta here, into L to the alpha K to the beta plus theta K. So what we're trying to do, it's just algebra. What we're trying to do in these type of problems is we're trying to rearrange the terms so that we can write it in terms of the previous value of Q. So we know the expression of Q before. Oops, sorry. Yeah, so we know the value of Q, I mean the expression for Q. This is the expression of Q. Okay, now we will, to get this expression, what we will do is we will take theta common. Let's say we take theta common in the whole expression. Okay, then we get what? L plus, here what happens, we've taken out one theta, so this becomes theta to the power of alpha plus beta minus 1, right, into L to the alpha K to the beta, oh, sorry, plus K. Now the question is asking for what values of, or what combination, or what condition will ensure that this particular function is demonstrating constant returns to scale. So for constant returns to scale, what we want is Q prime should be theta times Q. That's what we want, right? That's what we are trying to achieve. So in what conditions will this whole thing be true? This will be true only if this whole expression of theta, this becomes 1. Then what we will have left, if this is 1, then what we will have, Q prime is equal to theta times, this whole expression is nothing but Q. If this value, theta to the power of alpha plus beta minus 1, if this becomes equal to 1, then what remains in brackets? L plus L to the alpha K to the beta plus K, and the whole thing is multiplied by theta. So then what we get is Q prime equal to theta times Q. So what we want is, therefore, theta to power of alpha plus beta minus 1 should be equal to 1. Okay, this much everybody agrees. So now on what condition will this be 1? If theta to the has some exponent power and it must be equal to 1, then that means that exponent should be equal to 0, right? Therefore alpha plus beta minus 1 is equal to 0, and therefore alpha plus beta is equal to 1. So this is basically how you will approach any problem of this sort. What we will do is we will write the original expression q, then we will write q prime, and we will write it in terms of theta multiplying each input. So theta times L and theta times K. And we just write the new expression. Then we rearrange terms in a way so that we come as close to the original expression as possible. Then we, because it's asking you in what condition, under what conditions is this showing constant returns to scale. So in what condition will this new expression we get after rearranging terms become equal to theta times of original expression? And that is possible only if this thing theta to the alpha plus beta minus 1 becomes equal to 1. Then the expression in the brackets is nothing but q. So this is the condition basically which you require, theta to the alpha plus beta minus 1 equal to 1. So any number raised to the power of 0 is always equal to 1, right? So therefore you get this as the answer. So the answer is B, alpha plus beta equal to 1. Okay, this is today's last question, where you are asked what is the MRTS. So you want to try? I'll give you a minute to think or to solve the problem if you want. You're given a production function where Anne is producing paper boats and K is the sheets of paper she's using for making the paper boats, and L is her hours of labor. And this is the expression. Now, how do you calculate the MRTS? I'll give you a moment to solve it, and then we will do it. Okay, I'm not sure people are following, so I will just solve it. You can tell me if you have a problem. Should I wait or should I solve it? If somebody is solving, I can wait. Should I go ahead or should I give it a few minutes? It's almost time actually, but I don't mind waiting for 5-10 minutes. No answer, so I'm just going to go ahead. So this is a very common question. So this is basically a form of Cobb-Douglas function, right? Q is equal to, let's say, A, L to the alpha, K to the beta. This is Cobb-Douglas, and this Cobb-Douglas will probably not leave you alone as long as you're studying Eco 101 or microeconomics overall. So let's do the general case for Cobb-Douglas, and then we will come back to the values and the expression we have in the question, in my question that is. So now what do we do? MRS is what? So ratio of marginal product of labor and marginal product of, sorry, not MRS, MRTS is ratio of marginal product of labor and marginal product of capital. So let's first find out marginal product of labor. Okay, what do we do? This is what? Del Q by del L. Just making sure we're all on the same page. What is this? A alpha L to the alpha K alpha minus 1 K to the beta. Okay, similarly MPK is equal to del Q by del K. A beta L alpha. Oops. Okay, so far so good. MRTS is equal to minus MPL by MPK. Minus means what? If you're increasing one input, you have to decrease the other input, right? So minus A alpha, L to the alpha minus 1, K to the beta, 1A, beta, L to the alpha, K to the beta minus 1. Simplify this, just a little bit of algebra, nothing else. A and A gets cancelled. L, if you cancel L to the alpha, you get 1 L to the power of minus 1 remaining. Similarly for K, so what you get is alpha by beta and K by L. Or if you want, you can, just take this L to the alpha in the numerator. What happens? Alpha minus 1 minus alpha, what do you get? L to the minus 1. L to the minus 1 is what? L in the denominator. Similarly for K to the beta minus 1. Is everyone following this algebra? Because I sort of raced through a bit of algebra, but I'm hoping you will stop me if you have an issue with the algebra. So this is the general expression for MRTS. Okay, for Cobb-Douglas, that is not general expression for MRTS always in Cobb-Douglas. But don't memorize it. I solved it for the general case just so you know how to approach this whole family of questions around Cobb-Douglas. But please don't memorize it, at least preferably don't memorize it, because just by chance, if you get a question in which instead of L to the alpha and K to the beta, if they just flip it, if they say K to the alpha and L to the beta, your answer will be wrong. Okay, so be careful. Don't memorize which is alpha, which is beta, what is the expression. These are not to be memorized. This is very easy to solve anyway. I'm just showing this to you so you know how to solve this entire family of problems. Now, in our question, I think we have alpha is equal to 0.6 and beta is equal to 0.4, right? So what we get is MRTS is equal to minus 0.6 into K by 0.4 into L is equal to minus 1.5 K by L. So A is the answer. Okay. There are many ways in which you can get this wrong if you make silly mistakes, because if you know the method, you should be able to do it correctly. But a lot of times it's very easy to make very silly mistakes here and there. Just be careful of silly mistakes. Okay, so this covers this week's portion. So somebody had asked me about producer theory. Is there any other question you have on producer theory which maybe I have not covered or something? Please let me know now. I think I covered most of what was discussed in week 7 and 8 in producer theory. There's anything else left, please you can tell me now, or you can post it in the discussion forum and I will bring it to the next class. And that week 7 question, which I had given last class and we couldn't solve it in the live session at that point of time, I will upload the video for that. The thing is, I basically fell and injured myself, so there's a lot of things which went wrong last week. My computer was also giving glitches. So that is the reason why that video was not uploaded. And the notes were also not uploaded. I will have to find some sort of a hack to export the PDF from OneNote. So I will figure that out now and I will complete the whole set. Okay, so if nothing else, then we'll end the class here and I'll see you next week. Okay, thank you.